Hello. Today I am going to talk about introduction to IAS computer. My lecture covers these topics. First, I'd like to ask some questions to recap last class concepts, and I will tell you session objectives and teaching learning materials. I'll tell you session plan, the way I am taking this lecture, where I am spending, how much time, all these details. The next one is introduction of this IAS computer, and then characteristics of IAS computer, next assignments, and then I'll provide some references. Some reference. The first question is here. Name the founder of the World Wide Web. Yesterday I had shown you some of the pictures and introduced you to the some of the important persons who contributed to the computing science and engineering field. From that one I am asking you one question. Name the founder of the World Wide Web. Tim Berners-Lee. The second question is, who developed the analytical engine? Yes, exactly. It is a Charles Babbage. State reason for the failure of analytical engine due to the unavailability of device for the storage. Tell something about Ada Lovelace. She is a first programmer who programmed to the analytical engine which was developed by Charles Babbage. In Sun Microsystem, Sun stands for what? Yes, Sun stands for Sun stands for Sun stands for Stanford University Network. Well, the session objective to provide the fundamentals of the system and definitions of the computer. This is a session plan. I have spent already 5 minutes for the asking you question as a part of the recap and introducing you for the basics of the computer which you already studied in your first year, but just I am giving the basics. The next one is the IAS computer introduction. Next one is functionality of IAS computer, conclusion, summary. Well, let me ask you a question. What is a system? There are wide variety of definitions for the system, but I am taking one definition is here. System is one which takes the input and produce the output. If you see in this case, if you see in this case, so if you see in this case, so if you see in this case, this is a example for the electrical generator. Here fuel is the input, it is giving as the input and then producing the electricity as a output. So this is a system. That means this is the input and then this is the output. That means it need not to be every system must take the input and then produce the output. There are some systems which will never take the input and produce the output. There are some systems which will never take the input but produce the output. So this electrical generator is also a system. Electrical generator is also a system, and then educational institute is also a system. Doctor is also a system. How doctor has become the system? Doctor is a system. So he or she taking the symptoms of the disease as the input, and then producing the mm, prescription as the output. That is that is a system. So is there any system which takes the input but never produces output, and then output, and same thing vice versa? So there are some systems. If you hit, there is one system which takes the input but never produces the output. That is black hole. But there is another system which never takes the input but produces the output. That is a solar system. Well, so we'll go to the next slide. So similarly, there is a system. I am defining another system which is taking the data as the input and produces the information as the output. What is the data? Data is nothing but the collection of numeric numeric and non-numeric pieces. Numeric and non-numeric pieces. Information, the process data process confirmation is nothing but the meaningful data is nothing but the processed data or processed meaningful, that means putting the this data into the meaningful form is calling as the information. So example for the data processing system is computer. Example for the data processing system is computer. To define, let us see that one. What is the computer? There are different definitions I can give here. You see here, the first one is college dictionary is telling one definition, Hughes dictionary is telling another definition. This is the another definition. So there are different definitions are here. So in all these definitions, and then next one is the Oxford dictionary. There are a wide variety of definitions for this one. Wide variety of definition for this one, but I am giving a definition for this. The computer is a complex system which incorporates diverse technologies, typically electronic technology, and then for computation, and then magnetic technology for long-term storage, electromechanical for the input and output. If you will see here, this contains the diverse technologies. One is the electrical technology, second one is the magnetic technology, third one is the electromechanical technology. This is calling as computer. Actually, we have wide variety of definitions for the computer in various dictionaries. But in this case, I am defining a definition for a computer is something differently with the perspective of the computer architecture and organization. That is, computer is a complex system incorporating diverse technologies, which it contains like electronic technology for the computation. You see here, semiconductor technology which is using for the computation, magnetic technology which is using for the long-term storage, that means hard disk, the hard disk, floppy disk, and all these things, magnetic tapes, and all these things are the magnetic technology. Electromechanical technology. Keyboard is one of the electromechanical, using keyboard is using electromechanical technology, where when you pressing the one key, there is a mechanical movement converting the electrical signal, sending to the computer to translate it to the definition. So that is why I have taken this definition for this subject, for this course. Of course, there are many definitions, all may be right, but to satisfy the course requirements, I have taken this definition and then telling you that one. So in this one, the first unit we are talking about the overview of the computer. Second one is the computation details, how arithmetic, computer arithmetic. Third one is the memory technologies, how the memory has been constructed and designed. And then fourth one is something like input output devices. Fifth one is the peripheral devices, something like that. We will see these things. And then the next one is here. Computer architecture and organization. If you see here, so I have, our subject is computer architecture and organization. We have seen the definition for computer. Now I am going to define the computer architecture, and then computer architecture, and then computer organization. This is my second thing here. And then if you see here, these are the things here. What is this one? It deals with the functional behavior. It deals with the functional behavior of a computer that is viewed by the programmer. So this difference you must remember. And then what is the structure, the architecture, organization, structure relationship that are not visible to the programmer. Here, if you see here, this is a view to the programmer. That means here, this is view to the programmer. Visible, not visible to the programmer. And then here, if you see here, viewed by the programmer. So architecture will not viewed by the programmer, will be viewed by the programmer, like data size of integer and all this, clock frequency and physical memory, how much we are using during the runtime and all, we are not viewing all these things. The next one is, let us now, we have seen that what is a computer, what is the architecture, what is the organization. Now our title completed. Now I am going to the basic function of the computer. It is the basic function of a computer is the execution of the program, is a sequence of what is the program. Program is nothing but the sequence of the instruction which operate on data to perform certain tasks. There are arising two questions here. How are these instructions supplied to the computer? Second one is, how are they interpreted to the execution? So to answer all these things, definitely we have to see the basic architecture of the computer, which was introduced by John Van Neumann, calling as Van Neumann architecture. Actually, Van Neumann, almost all computer designs based on the concept developed by the John Van Neumann, referred as the Van Neumann architecture. Virtually all contemporary computers are based upon the concept developed by John Van Neumann, who designed the IAS computer. So this is the IAS computer 1952, and then you can see the diagram of this one. It is very huge, very big computer. I can show you at the end of this class the video where you can see this analytical engine. This analytical engine 1940 developed at Princeton University, and then it is the IAS, nothing but the Institute for the Advanced Studies. What are the characteristics of the IAS computer? So the characteristics of the IAS computer is nothing but there are 1000 words in this one. So for each word is 40-bit length, and then a sign bit and a 39-bit value represent each number. You see here, first you should know that one, what is the word, what is the word length, and all these things. So let me take you to this. You see here, for example, this is a memory. So each memory, that means each memory is made up of with the group of the semiconductor cells. So like this will be there, semiconductor cells. And then here the computer, that means the computer CPU rarely reads the individual bit. This is a calling it as a bit. This is calling as a bit. It reads either 0 or 1. It reads either 0 or 1. And then the computer rarely reads the individual bits. It always reads the group of the bits. The minimal part of the maximum part of the memory which is read by the CPU is calling it as a word. Calling it as a word. There are many words like this. This is one word, and then this is second word, this is third word, this is fourth word. That means there are many words. To distinguish from the one word to the other word, there should be a unique number, calling it as the address. Calling it addresses. For example, this one is 0 0 0. That means 0 0 1 second memory location, and so on. We can say that 1 1 1 1. Totally 8 memory locations in this one of the 4 bits. We can say like this one. So how to calculate the total capacity of the memory? So this is the word. The number of bits in a word is calling as a word length. Number of bits in a word, number of bits in a word, nothing but the word length. And then number of bits in the address called address width. So word length. And then here I will write here number of bits in address is called as address is called as, we can say that one, address width. So the thing is, the formula is here for this one, 2 power address width into word length is equal to total memory. This is the way we will calculate it. In this case, if you see here, there are 4 bits in a word, so that word length is 4, and then 3 bits in a word address. So 2 power 3, and then this one is equal to 8 into 4. That is equal to totally 8 into 4 is 24 bits. Total capacity, this is total capacity is 24 bits. Now such a things are here defining that one. If you see here is telling that one, this is totally 1000 words are there, and then each word length is 40 bit. And then that word length, and then there is sign bit. That means data should be the sign bit. So that this is that means the sign bit is 40 bit. Sign bit is also, that means the word length is, data word length is also 40 bit. This is the magnitude of the integer, and then this is a sign bit. There is a 20-bit instruction, and in this 20-bit, 8-bit is opcode. That means opcode, operation code means the operation which is being performed, and then 12-bit is the address. So actually here the total length is 40 bit. Here 40 bit. What is the length of the instruction? Length of the instruction is 20 bit. Length of the instruction 20 bit. So that in this 40 bit, so 20 bit. So this is a 20 bit, and then one instruction, and then this is the another 20 bit in the another instruction. So what is the meaning of this one? We can have 2 instructions in a single word. The word length is 40 bit. If you see here, the word length is 40 bit. The instruction length is 20 bit. So that in a single word we can accommodate the 2 instructions, because 40 by 20 is equal to 2. So that we can accommodate the 2 instructions. These are the features. Once again, I will tell you the features. It contains 1000 words. What is the word? The minimal part of the memory which is accessible by CPU is calling as a word. The number of bits in a word is calling as a word length. The word length of this IAS computer is 40 bit. So the data world, the data length is data world size is 40 bit, in which 39 bits are the magnitude, and then the 1 bit is a sign bit, and then here it has a 20 bit instruction. In this 20 bit instruction, 8 bit is operation code, that means operation which is to be performed, like add operation, subtraction operation, multiplication operation, and so on. 12 bit is for the address, and so that in the 40 bit word length we can accommodate the two instructions of the each 20 bit length, 20 bit length. And then here, yes, so let me show you that one IAS computer animation here. So in this one you can see here accumulator. This is the accumulator which hold the one of the operand or address of one of the operand of the computation, result of the computation. Multiplier quotient, I will tell you later what is the significance of the multiplier quotient. Arithmetic logic unit, which is used to perform the arithmetic operation, logical operation. Arithmetic operations such as addition, subtraction, multiplication. Logical operations such as AND operation, OR operation, exclusive operation. And then MBR is one which holds the data which is coming from the main memory to the accumulator or multiplier quotient or any one of the register, or else the computation results also going to the main memory through this MBR. Before that means it is just like a buffer which is acting as an interface between the main memory and the accumulator. And then IBR, instruction buffer register, I will tell you the significance, because we will have the two instructions here, and then one of the instruction will be, that means two instruction in a single word, there will be two instruction in a single, there will be two instruction in a single word. So that what we will do here, one of the instruction will be stored, the right side of the instruction will be stored into the IBR, instruction buffer register, we are calling it as. Program counter, which will having the address of the instruction to be fetched, and then memory address register, which is having the address of the memory location from which the instruction will be fetched, and then IR is the instruction register. So it contains the opcode, what kind of that will decode that instruction, and then generating the control signals for what kind of operation to be performed. This is the main memory. Let me show you that one. Let me show you so this is about the IAS computer. This is about the IAS computer. So we can see one more time here what is happening here. The program counter address will be transferred to the MAR, okay, MAR, and then MAR passed that address to the main memory, and then the main memory passed that value to the MBR. MBR contains the two instruction. The right part will be going to the IBR, and then the left part IR will be going to the IR, and then to get the operand it will go into the MAR. And then the next one is here, it is going to from there to main memory, and going to the MBR to the another operand is going to the accumulator. This is what happening in this one. Let us see that one, the summary of this class. So summary is data processing system, definition for a computer. We have seen that one IAS computer characteristics, block diagram, functionality, and all these things. The reference for this one is William Stallings textbook. We can see the IAS computer architecture and all those things, and then this is also the history. Some of the pictures I have extracted from this website. You can also verify that one. Thank you very much.